Okay, so let's continue the image filtering and implement the pthreads version. So since last time I did a bit of refactoring, I've split the code into including SRC so people know that I know how to use header files and C files. So something else that I did was to add another argument here called p or threads that will give us a number of threads that we want to use. So basically, if we have only one thread, we are going to use the single thread version of the image filtering, and otherwise we'll spawn multiple threads and do the multi-threaded version. So right now, if we run make and try to, yeah, let's take the image for the mouse or whatever. So if we don't pass anything, it will just run it with a single thread. And if we pass p4, let's say, it will say that okay, it's not supported yet, we have to implement it. So for my idea on how we're gonna implement this, let's say we have the image, okay, and based on the number of threads we can split it into strips like this, and each thread will have to apply the filter on one of these strips, right? So basically, to have this kind of functionality, I was thinking to update our apply image apply kernel function that if we go to image.c um, image apply kernel, it just iterates through all the um, like all the pixels and applies the kernel like that. So my idea is to add some arguments to this function and like have, let's say, a bounding box where the filter will be applied. So for this we are gonna use, for the start 0 and width, and for the height it will be the number of the thread multiplied with the size. For I think this is like for the end, and for the start is with -1 for size, or yeah, whatever. We'll see how big the height will be for the strip itself. So yeah, first let's see here how um, are we gonna change this, right? So maybe we can just create a new function actually, just in case. So it should be image apply kernel patch, and we are gonna have the struct image struct kernel. Okay, then we are gonna have so we need 4 indices for each corner of the bounding box. So let's say we are gonna have we could send a 4 integer array, but what's hard about it is knowing which one is which. So let's say start x. So we're gonna pass in all of these, And I also think I want to pass in the pointer to the output image, so something like struct image pointer out. So we allocate it inside of this. So now let's go to main.c, and for example here, instead of well, yeah, of course we could do that. But first let's say something like this, and here we need to somehow call this thing. So let's pass in the image. Here we're gonna need the values for these things, and here we are gonna need the output image. So for the output image, I'm thinking we're gonna do this. Like this will be so we need the width, height, and the number of channels of the image for this. I mean, we can create some functions for that, or we can have another function that duplicates like an image, you know. So it could be something like image like, you know, like something like that. So let's do struct image pointer image like, and it should create a copy of an image. Let's see if this okay, perfect. So yeah, pretty much we're gonna call to image new, but you know, return image new, and it creates the image. Let's go back to this one. So this will be image like image. Wait, whatever. So this will be the new image. Okay. So this is just like a comment here, how we're gonna call it. Okay, so now, to be honest, we need to search pthreads example. I mean, probably this will be the best example though. So we need pthread.h for the for pthreads. Then we have the thread function. It can return a void pointer, but doesn't really matter, I think. Okay, we need to define a list of pthreads. So yeah, let's say uh, you can't really, I don't think you can do this, although it would be nice, but doesn't make sense to be able to do it, to do this. And then we need to call pthread create. So for int I equals 0, okay, basically uh, mm, yeah, whatever, let's put everything like this. So pthread create, I think it receives the pthread structure, the reference, then it should be like some options. I don't remember exactly what. So let's see, pthread docs. Oh, so we could have just used man for this. Okay. I wanted to see like mm, I guess we can also use the LSP for this. So we need the a pointer to pthread. Then yeah, some attributes. I'm not sure what exactly we can specify in that. Then it's the start routine, which is the function, and then the arguments. But for arguments, yeah, it looks like you need to pass them as a structure. So that means we need maybe to create a wrapper for this. Okay, so yeah, let's create a wrapper for that function then. So we're gonna need a struct. Okay, first let's have the function void. Let's just copy the name and add something like thread to it. Thread. Here should be like a void pointer, but void pointer args, void pointer args, and I mean let's create a structure. Struct thread args, and in this thing we're gonna need mm, yeah, pretty much the arguments of this function. So if we copy this stuff, put it here, let's okay, I mean that will fix it. Okay, so these are the arguments. I mean, probably you should be able to say struct thread args here. Okay, and here we just need to apply the function. So this thing. But yeah, like args, and then we need to access each stuff. So args again. Okay, like just call it like this. Hopefully it doesn't mind that it's not void pointer, but we don't really care. So here we need thread. And now we have to create a structure. So let's say first, well, I don't think we need to allocate anything. I think we can just do, yeah, just do this. So here it doesn't like that. It has to be void pointer. Okay, so it has to be void pointer here, and also void pointer here. Yeah, and then let's say, let's just rename args. Hmm, I don't think we can do this. Yeah. Anyway, yeah. Wait, but it still has to be just void pointer. I mean, it's still fine, right? Like, yeah, looks good to me. Like this will be a pointer to thread arcs, it will be converted to a void pointer, and here we cast it back to a pointer to thread arcs. So it's fine. Okay, so here we apply this function on the arguments, and basically new image should be changed, right? So at the end we have to call pthread join on each of these, and my guess is that new image should be done if everything works well. Well, we actually have to implement this function now. So let's come here, and we might want to just copy paste this stuff because it's gonna be similar. Like, to be fair, it's gonna be very similar because here instead of 0 we are gonna use start y, here we are gonna use end y, start x and end x. Yeah, so basically it's just the function from above, but we do only a patch, so also here should be out. Okay, anyway, so I was just thinking maybe we can delete this, or like use here uh, like this. Yeah. Mm-hmm. Yeah. Okay, so I think uh, I that should do it, maybe. It was something like log error. Yeah. So new image, we just apply. Okay, let's run make. First, let's use only one thread and have output 1, and now let's try to use 4 threads and say output 4. Okay, and I have also implemented a small tool. It checks the difference between two images. I mean, it goes through all the pixels and it counts how many are like above a certain tolerance, and the tolerance is 10, like 10 for between 0 and 255. I mean, we can check. Well, first let's look at the images. Who knows if we broke something while we're doing the thing. Okay, I mean, it looks the same as before. And this one, okay, let's not talk about it. Let's let's try and see. Oh my god. Oops. Yeah, I forgot about start and end. So, as I said, we need to create the size of the patches, right? Yeah, but see, we still need the need the width and the height of the image. So let's have here int image get width, image get height, and get channels. Yeah, because since like we define the structure like this, we can't access the fields in other C files, right? We need to do it using functions anyway. So let's take width, image get width and the height. Well, yeah, sure, fair enough. We need the width and the height. So um, patch. I want to do height. Patch height. That's interesting. Well, it's gonna be an int. So how are we gonna do the split, right? So we are gonna have the height. Let's say divided by 4. It gives us like something something, and then the last patch will be something like really small. But so yeah, let's say the height is 9, for example, and do the 4. We're gonna get 2's. Yeah, I mean, whatever. We're gonna make the last patch a bit larger or something. So patch height is gonna be this division, okay? And then we are gonna say here start. I mean, start x and end x will be width. So start will be start y will always be I times patch height will be like this. So this point, then this point, and so on, like the start. And what I'm thinking is and y will be I plus 1 times the height. And if we are at the last thread, we give it the entire like it would be from here to here, but we still have this piece left, so we give it the entire portion, the entire patch at the end. So start y will be start y and end y will be end y. Okay, let's rebuild this. And now if we look, that's interesting. See, I think somehow, but it shouldn't. Like the last portion of the image is fine, right? And the other strips are not fine. I mean, I don't remember this function to do like, hmm, like even if we run it multiple times, I would expect other chunks to start to be visible, but no. That's pretty weird. Let's see if we do, I mean, if we do it only one, it's fine, but yeah, let's printf these start values. Printf, and let's see. So it's gonna be 0 and 25, 25 and 50. Like, sure, it makes sense. Threads I is fine. New image is already created here. So it's gonna be like a blank image. Uh, we pass in the original image. Yeah, maybe, like I was thinking that if we don't modify the same spot, this would be fine. But what if we actually need some logs, so it doesn't make sense to create a new image here? Maybe it would make sense to have a new image for each and then combine them. So let's say we have, like, we split the new image actually to be strips like this instead of the whole image, and we pass each strip individually, and then at the end we combine the like the image. I mean, in some way, what I would do then is here not get image out, maybe returning the image out, and creating a new image, basically, for each one. So let's try that. Let's have here struct image. So this will return the size of the, like an image with the size of the patch, right? I was trying to be smart about it and try to avoid this, but yeah, so we have to create a new image. So basically the image width will actually be start x minus end x. So in this example we had 25, which is good. Then this and channels. Okay, so here we struct image pointer new image equals this thing. We no longer need this. Oh, so we can just return it. It's like a wrapper. Do not care about zeros in these arguments. Perfect. So now we have the new image as it's only a strip or like a chunk of the image. It takes like a snapshot of it. Okay, so here we have new image and we return the new image. Okay. I mean, let's still keep this stuff and all the other functions. They are like maybe semi-useful. So okay, now we allocate, right? So that means we can actually return this now. Okay, we can actually return it. So going next, we don't need to allocate the image. Maybe we can have here, let's say this is an array of size threads. It will be zeros. Like, doesn't really matter. It doesn't even need to be pointers. Oh, it has. That's kind of bad, or I'm not sure. Okay, so we don't care about this thing. Okay, let's create this here at the bottom, so it's closer. So this is for the threads. Okay, here we create this, and we need to, instead of having here null for the argument, we need to yeah, this will be interesting. Well, let me, oh wait, I forgot about the LSP. Oh yeah, so it's a void pointer pointer. So then it's fine. Okay, so now we have the four images, or like P images, and we need to combine them. Let's call this images. Okay. Well, the order is guaranteed to be sorted because we use here thread IDs I, so the order is fine. Now we need to create a new image like image. and then we need to, we already have width, height, and all that stuff, and also patch height. So I think we might have to do something like this again. We might need to iterate through the threads. Okay, and then oh, we also need the number of channels. Let's put it here, int channels. Why not? Oh, I'm thinking if we could use memcopy for this. Let me check. Let's include a string. I think it's memcopy. So we get a patch to the image and then memcopy. Oh, we would need access to the bytes, but we would say start y times width times channels. Because I think the image is stored, yeah, like this. Wait, so when we say get pixel, basically that's what we are gonna do. I times width plus 0 times channels. Yeah, that should do it. Yeah, but we're gonna need access to the bytes. Well, I mean, whatever, let's... And this will be end. Well, this should start from 0. Like why? Let me see. Memcopy is n bytes of src to dist. Yeah, I mean this should be. Oh yeah, it is 0, and then the number of bytes is end minus start times width times channels. Okay, perfect. So that's like how I would copy, but as you see, we need the bytes. So let's go to image.h, and here let's say assigned char get image data, and here we just return the bytes. So if we go to main.c, we get actually the assigned char new image bytes and unsigned char patch bytes. So here we have new image bytes and patch bytes. And then we close this. It's interesting. Let's check. let's first make it. So I mean, these look good. Okay, let's just save the new images, right? Like right image, right bbm, new images. I don't know about the file name. I mean, we could do like char patch name and then as printf and then use it. So let's see how the patches look like. Wait, what? Yeah, that's pretty weird. I mean, I don't think this. Oh, why is it minus 100 and minus 25? Okay, so something went wrong then inside of this. So like when I create start text, when I create a new image, oh my god, it's end x minus start text. Why did no one tell me? Start y. Yep. So if we run make again, then we do this and we check the first patch with fe. It's blank. Really interesting. Let's get. Wow, it's. Wait, what? I mean, it should like hex dump. Yeah, like it should have zeros at least, or something. Okay, pretty strange. I mean, we can debug it further with our printf method of debugging. So here, let's see something like, I don't know. So everything is, why is it always 75? Oh my god. Ooh, this looks bad. Is it really because I do? Does it really work like that? I'll be honest with you, I don't remember. So then it means that the new image was actually fine. It was this thing that didn't work. But then, yeah, I mean, do we really have to malloc it? Like, that's a strange thing. We really have to malloc and then initialize it with whatever values. So, yeah. Oh, for sure this should be arrow. I mean, then we can free it, so it's not a big deal, but does it really? Wait, why though? Something went wrong inside of this function. So let's see what happened to xy. Oh, something did not initialize well. And I think I know why. Because here, wait, where is it? Here we need to pass args like this. Right, we no longer need to do the address. Or do we? Like maybe we need to pass the address. Like I don't get it. Like, why is it 0 and 75? Is it really because of this kind of stuff? So here should be a double pointer and we dereference it once. Okay, okay, let's try again. This time let's create, because like I cannot. Okay, let's try it like this. Right, let's say I dot image, and here we're gonna pass. I mean, plus I works for me, and here it's just a pointer. Like, do we really need to create each one? Like, we cannot. Yeah, wow. Oh, patch 1 is black. Interesting. Patch 2 is also black. If we run this thing again, now doesn't change anything. So yeah, this is not ideal. Well, since we already have inside of we already have to create arcs, let's put the out image was still here. Okay, then let's put inside the out image the image, right? Like so this will be a out equals, and let's not care about uh, like at the end. I think we'll have in args will have the out image. So here let's say args I out equals null, and now instead of having to create this stuff we can pass here null. Okay, so here it's args I dot out. Let's see if this changes anything. Oh my, make. It's still only one patch, which I mean this is printed from the image. Okay, I mean let's leave it like it is. Let's just remove this from here, and here let's leave it as return. It's fine. I don't mind. So okay, let's see. So this thing looked good, right? It was showing what it needed. So it means that it goes inside of this loop. The image size is fine. We saw that like all the patches look the right size, but this thing, well, here we assume that it's image width, which is not really ideal. Let's say so. Here it should be new image. Here should be new image, but I couldn't imagine that this has to do anything with it because our patch width is the same size as the yeah, like it's the same size, so it shouldn't affect it. Okay, I mean let's just print f x and y. See, like it's not that many, I think. Well, yeah, it looks like it's going through all of the values. Yeah. So this works. And like, I mean, let's say we just show it the moment it's done or something. Yeah, but I don't get it here, like why it's not. Okay, let's do with only one. Oh, let's make again, and let's do it only one. So this should be just one patch. Can we see? No, patch didn't do anything here. So if we do two threads, it's only the top half. Is it I mean, it's not even wrong with memcopy because the second patch itself, it's not there, like it's black. Oh, I mean, patch 1. Okay, I'll try to put this inside of image. Here at the end we don't have I, but we have like maybe, so it's new image, and here it's gonna be like, I don't know, start Y, because that's what is changed. So let's remove all the .bbm stuff. Let's make this and let's run it with 4, doesn't matter. What? Something went wrong for 25 for some reason. So this looks good. 50 is black, like what? Bro, I swear. There's something stupid, like, oh my god, when I compute the freaking coordinates, I, I even went here once, so wow, I'm so dumb. So index, like the index in the image needs to be offset, right? It should start at this and end at this. So we actually need to subtract start y from y. It should be y minus start y, and times width, and from x we need to subtract that. And yeah, I mean the channels is channels, doesn't matter. I'm still curious though why did a seg folder. I mean, why didn't segfault in the first place? Okay, wow. Let's see the patches. See, like now the patches work. Yeah, I'm so. This was a good one though. Now, you know what? I'm curious if having only one new image would work. Well, it didn't because I didn't because this was like made for it. So, and it didn't work when we had it. So yeah, I think. Yeah, like it would be interesting if you could, let's say, here have the image, then say apply kernel patch, and it would like return the same image like this one, but with the patched colored in, something like that. Because I think that here in our main function, I mean we passed the original image. So yeah, I mean for the purpose of this kind of project, I think it's like whatever, it does the job. So now can we div the two images? Okay, let's first create. No, let's first make. Let's remove all the stuff. So we have just the input image. Okay, so let's create this one, and let's create a single threaded one. Let's see if, I mean, it shouldn't be any differences. Oh, I need to pass like minus I and minus D. Yeah, this is why I should implement the positional arguments for the arc parse, but images are the same. Oh my god, that's good news. Perfect. So yeah, basically what's left is to make the same thing but for CUDA, like apply the filter in image filter using CUDA, and then test how fast it is. Like let's copy this uh, image. This is like the one wallpaper that I used, and let's try to apply the filters on this image. It's like a bit larger. So okay, let's do, so this would be single threaded, and for minus p4, this would be on 4 threads, and let's see the diff. Okay, so they're the same. It means we can try and see, I mean, you know, like maybe trying to have um, more filters applied one after the other, just to see like on multiple filters. I'll be honest, I don't know how to read this in Fish, but I mean executed in, is this the time it took? And I mean user time should be pretty much the same because it adds all the threads together. Let's try more. I mean, I'm not sure. So this was faster. Can you do something like CPU info? Uh, get number of threads. I mean, let's do get number of processors in C. I know it was like one. Well, I mean, okay, so 24 cores. Then let's run a make. Let's see. Let's make clean because we overrode the. So we can actually do 24. This would be like the max. But yeah, like if you run it multiple times, I mean, you can see the difference. With 24, it's like around 120, and with 16 is like around 130, and with only one core is around 400. So it's uh, almost 3x speed up, which is yeah, a good result for now. And what's important is that the images are the same. Look, I mean, it looks a bit blurry. And what we can do, let's say we do 24 and then apply on output 4, we apply again. Yeah, and maybe also it's some time lost because of reading the image itself. So okay, we applied enough. Let's see. Yeah, it looks really blurry now. So one thing that maybe we can try and do is, what if the filter is like blur and then again blur, so like you can have a pipeline of filters, but yeah, like that would make it simple to do this kind of stuff, right? But it's okay. Let's see now. Yeah, really blurry. Oh yeah, and something else that I added was more filters. So if we go into kernel.h, now we also have sharpen, edge, and emboss. So let's see what happens if we apply edge, if we edge the image. Looks interesting. I mean, probably see, like you can actually see the RV. And what happens if we sharpen? It's more sharp, obviously. And emboss, I think it was something weird. Emboss. Yeah, it makes it like it looks a bit 3D. So let's also do for one thread, see the diff. Yeah, I mean, what's really nice is that the images are the same. Okay, let's try to be more strict then. Let's do tolerance is 1. See the diff. They're the same. 0. Oh, I'm disabled. Okay, so yeah, even with 0 it works. But I would keep it 10 because who knows? Like a floating point disaster and they are no longer the same. But yeah, it looks like the filtering works. And this one looks really nice. It looks like this is some kind of weird dirt stuff. And for the sky it looks like the clouds are closer. This and this. Yeah. But I mean, look, 130 milliseconds and for almost 3 times speed up. So oh, it's output one. Output one was blurry. Yeah, and it looks blurry. So yeah, I guess we'll see each other when I have to do this in CUDA.